This video will be talking about the subject matter of solving one-variable equations and inequalities. Our learning outcomes will be to solve linear equations and to solve linear inequalities. I will be referring to the Homework 1 My Notes. To begin, before we can actually solve a linear equation, we need to identify a linear equation. Your textbook states that you can find a linear equation in one variable if it looks in this manner. However, I think the easiest way to think about a linear equation is any equation in which the variable that you're looking for has no function around it or no exponent. For example, you want something that looks like 2x squared plus 5 is equal to 0 is not a linear equation because our x has an exponent to it. Same thing if we would have had 2 times the square root of x is equal to 7. Again, this is not a linear equation because there's a function being done to the x. However, if I had 2y squared plus x equal to 3, we can see that this is a linear equation if I am solving for x. It is not a linear equation if I'm solving for y. So whichever variable that we are looking for does not have an exponent, then we can say that that equation is a linear equation in terms of that variable. The next thing we need to make sure we talk about is applying the golden rule of algebra. That's pretty much what you do on one side of the equation, you must do to the other side. So in other words, if I have two things that are equal to each other, let's say A is equal to B, then I can add anything I want on one side as long as I add it to the other side. So think about this being the golden rule of algebra. What you do to one side, you must do to the other. Whether it's adding the same constant, or subtracting the same constant, or multiplying by a constant, or dividing by a constant. So that would be our golden rule of algebra. The other thing we need to realize is that when we're solving any linear equation, the result will be one of the following. It will either be a contradiction, conditional, or identity. So let's talk about those three different scenarios. When solving the linear equation, we can either have 0 solutions. That means that we have no solution, and that this is what we call a contradiction, and our solution set will be an empty set. If we are looking at a conditional, that means we get one solution that will one condition that will actually satisfy the equation. That means we're going to find x value number, whatever that may be, and our solution set will be that number. Lastly, we can have the identity in which we have infinite many solutions. That would be infinite many solutions. This is what we call the identity, and our solution set will be all real numbers. So when you're doing the math, what's going to happen is that when you're finding the contradiction, you're going to get something that contradicts itself. Something like 0 is equal to 3, which is not true. If you're finding x and you actually find the number, then you have found the conditional situation. And last but not least, if you're finding the identity, it's because you're finding something that says 3 is equal to 3 or 0 is equal to 0. It's not contradicting, but it is definitely telling you the identity property when you're solving. The last thing that I want to mention about solving linear equations is break-even problems. Just to give you an understanding of break-even, it's when you have revenue, usually represented by a capital function R of x, where x is going to be the number of things that you're going to make and sell. And then you also have the cost, represented by C of x. And so when the revenue, which is the money that you get after selling whatever you made, is equal to the cost that it took for you to make those items. So when you think about a break even, it's going to be that the revenue and the cost are equal to each other. Now, usually in business, you want to make sure that the revenue is going to be at least the cost. So you actually want to get more money in than you spent making the items. So let's move on to solving linear inequalities. So let's start by talking about properties and notation. I created this handout, which is located in the homework number 1, My Notes. So I like it because I have placed the properties up here. So the big thing to remember here in terms of properties is that if you're adding or subtracting, the inequality sign stays the same. However, if you are multiplying or dividing, that's what these two are talking about. If you're multiplying or dividing by a negative number, that's this part right here, then the inequality sign will actually change. Looking at some notation, we can see that we can have it in what we call set notation or set builder notation, and then we can also have an interval notation. So this is the one we prefer, so make sure that you understand what that means. If we have an open interval, notice that we have parentheses on everything in our interval notation, and on the graph we're going to have big parentheses as well, denoting that they're open. We can have a combination where we have some of them that are closed, that would be our bracket, and then some part is open. So you can see that here, that this is a bracket and that this one is open. Then we can also see closed, which we talked about, both of them would be in brackets. And then if we have two parts that we want to talk about, we call it a disjointed interval, and they are united with the union symbol. So we're talking about two parts where the value can be between negative infinity and a, but not including a because it's open. And then it can also include any number greater than b all the way to infinity. And if we want to represent all real numbers, we actually state it as negative infinity to positive infinity, and notice that everything on our graph has been shaded and has arrows at the end to indicate that it goes on forever. So the manner in which we solve inequalities, linear inequalities, is we solve them as if they were regular equations, except that we make sure we switch the inequality sign if we multiply or divide by a negative number. Again, as we showed in the notation part, you should be able to graph the solution on a number line and state it in interval notation. Sometimes to make that decision of which side you want to shade, sometimes it's good to test a point or test an x value, and if it's true in the original inequality, you shade that side. And the last thing I need to talk about is going to be solving three-part inequalities. And notice I gave you an example here only because I wanted you to realize that these are the three parts we're talking about in terms of the inequality, and you solve it as same way that you would be solving an inequality problem. Kind of think of it as you're solving this part and we just want to solve for x, which means I need to subtract 5 to both sides. So what we're going to do, instead of subtracting 5 to both sides, we're going to actually subtract 5 to all three parts. So now we can see that I'm going to have negative 7 is less than 3x is less than 15. And remember, what we want to do is solve for x. So you can see from here the next step that you would have to do. In fact, this is one of the examples that you're going to see in the list of examples provided by the textbook. And that concludes this video.